Hello, my name is Amos Tarfa. I'm a medical physicist based in Texas and a math and science curriculum writer. I've been writing math and science curriculum now for over 10 years. And in this video, I want to share with you the math remediation problem, the solution to the math remediation problem, how we can solve it. I've been studying the math remediation problem for about 12 years. I came upon the problem right after I finished teaching at a high school. So I've taught mathematics to middle schoolers, high schoolers, and college students. I've designed math programs for elementary school students as well. And so it's interesting because I've looked at the math spectrum from elementary, middle school, high school, college, and the PhD, like the whole spectrum, right? And what I realized is back in 2013, I wrote a book, 2013-2014, called Tools for Mastering Mathematics. This is a resource I can send to you for free to check out so you understand some of the ideas that I talk about. But what I realized was the more I study people like Isaac Newton, the more I study some of the greatest mathematicians who've ever lived, I noticed a pattern, right? They learn mathematics by mastery and not grade level. The idea of grade level mathematics is actually part of the problem. So there's a few reasons why students struggle with math. I think one of them is that we actually teach it on a grade level basis. That in and of itself is a problem. We can discuss that in another video in detail. But students, especially when they get to 5th grade and above, they should move based on mastery and themes on what they're learning. That leads me to the other problem in math education. And that is the problem of class titles. The very fact that a class called pre-algebra exists is a problem. Because what is pre-algebra, right? Pre-algebra is addition, subtraction, multiplication, division, and then you do algebra 1. But when should you do algebra 1? Well, you do it when you've mastered pre-algebra. Well, some states say you should do it in 8th grade. Some say in 9th grade. How about we just step back and say, you need to know how to add, subtract, multiply, and divide. You need to know fractions, decimals, percents, ratios, and proportions. When you've learned those things and have mastered those things, then you go into algebra 1. Now, what is algebra 2? That's another story. In America, you can live in the same state and just be 5 miles apart with somebody else, and your math curriculum can be very different. That person could be learning in algebra 2 equations. You could be learning in algebra 2 some other random topic. Some schools call it college algebra. The names are actually a problem. They're much bigger. Like, they're a bigger problem than we're willing to admit. Okay, so I know I'm going to dive into the solution for the remediation, but how did we even get to this point where we need so much remediation? Well, because number one, we don't have a comprehensive discussion framework for what we're talking about. And I'm not trying to tell us to start a program that presents math in a low bar. No, I want every student to do calculus independent of whatever they want to do with their lives. Why? Because calculus is beautiful. Just that it's beautiful. But if we want to get on the practical side, there are many reasons why they should learn calculus. But our current education system doesn't have a unified high bar for excellence for mathematics. That's part of what I'm trying to solve. So we're solving the K-12 math problem while solving the remediation problem at the same time because we need everybody everywhere to love math and to flourish in it. There's no time to fix one and wait for the other. We have to fix the whole thing. So we have the K-12 problem, which involves classes. Let me list another class, pre-calculus. What does that mean for somebody in Minnesota versus someone in Texas versus someone in California? It could mean a variety. Oh, there's honors pre-calc. There's pre-calc for this, for college credit. There's pre-calc for no college credit. Can we just take math topics, all the topics that need to be mastered? And again, we have to determine how far do we want students to go. For me, it's calculus 1. Statistics, data science, linear algebra. That's my base. That's the base level, right? And it's doable, right? There's no reason for summer breaks. And I know in this video I've dropped several intense things that we have to change, but we have to move. We have to move quickly. The times are upon us. If somebody does not know mathematics at this time in 2026, their options in their future are going to be very limited. Because AI is based on mathematics. Quantum computing is based on mathematics and physics. Space exploration, I'm not going to space, but space exploration is based on mathematics. Medical physics is based on mathematics. Even economics, I mean, I argue it's STEM. Some people say it's social. No, economics, again, is mathematics. Everything is mathematics. So we need a solution and we need to move fast. My recommendation, by the way, is that there's no summer break. This summer, 2026, there is no summer break for anybody because this is a state of emergency. Like, this is serious. We are living in very interesting times. And if we don't take it seriously, Like, some children are going to miss out on many opportunities. So that's why I keep moving back between the K-12 and the college. I've also taught in the K-12 and the college setting. So what I'm saying is, can we just be unified? Okay, so when somebody says, I am doing addition, okay, we know what they're working on. Or I'm working on graphing. Okay, great. Can we know what we're even talking about? That's one of the problems with, and I discuss some of that in my book, Tools for Mastering Mathematics. I also provide that comprehensive list in my book, Tools for Mastering Mathematics. So you can literally see a comprehensive list from counting to calculus in one sweep, and you can look at the names of some of the mathematicians behind all the concepts that we're teaching. So that is the first thing we need to solve. Before we solve the college remediation problem, we have to address the reason why it's there. And it's there because the system is so broken in mathematics education that the best thing to do is to actually start from scratch. We need to start from scratch, but we need to recognize that we cannot have a low bar. America has tried to have these standardized models for education, for math education, and one of them led to serious controversy. The Common Core, it led to some controversy. And I'm not going into that in this video, but my point is we need to recognize having a goal set is not the problem. The standard and the methods for that to be accomplished are some of the issues that happen. Singapore has a goal set. Singapore has a Federal Ministry of Education. In their mathematics implementation, they have standards and they're doing very well. Nigeria has standards, and for the schools that are functioning, they're doing okay, they're doing well. I'm not saying students love math in all the schools, but they're doing pretty well. America, I think we're all over the place and there are solutions, but there is no time to, there's just no time to waste is what I'm trying to get at. So we need to solve these things and we need to go on overdrive quickly because our students are watching AI disrupt everything. And if AI is disrupting things in different industries, the question becomes, what are the tangible fundamental things that will remain? Mathematics is not going anywhere. Logic is not going anywhere. But if a student doesn't love math and struggles in math, well, what can they look to help them prepare for an uncertain future? So we need to fix the math education paradigm quickly. Okay, now let's talk about college remediation. So for the college remediation, the way I would look at it is I call it, there's a human approach to solving the math remediation problem. And the way we fix that is that we basically think of the traditional approach. Here's practice problems you need to work on. You need to do, there's these drills that you need to do. There's this practice, focus on all these gaps that we need to fix. But the problem though is some of the students that we're trying to help, they have an internal struggle. They're a little anxious, they're discouraged. Some of them feel like they're behind. Why am I doing Algebra 1 again and I'm in college? Many are convinced that they're simply not math people due to past failures. Stress and life circumstances contribute to the gap. It's not just about the math, right? So we are basically seeing that some of the students in the setting that they find themselves in, they're concerned, they have other issues beyond just the fact that they're not good at math. So how do we fix the remediation problem? I'm going to break that down in the next segment of this video. But in this first part, we've talked about the fact that we have problems. We don't have a unified language for understanding math education across states and across districts. Algebra 1 in one school might look quite different from Algebra 1 in another school. Pre-calculus in one school might look very different. Pre-calculus is offered as an honors course, is offered as dual enrollment, is offered as a non-honors, non-dual enrollment. There's too much going on. Let's bring it all together. Let's begin to navigate math excellence for America. This is my roadmap for math excellence for America and anybody else who wants to become very good in mathematics, like people like Isaac Newton and James Clerk Maxwell. Let's dive into that in the next part of this video. Thanks for watching this first part. Feel free to like, share, and subscribe. We'll pick it up in the second part on college remediation. Thank you for watching and have a blessed day. So how do we fix the math remediation problem? Well, we've talked about the problem in the first part of the video, and now we're going to dive deep. As I said, I'm a medical physicist. I've been writing math and science curriculum as well for many years. I've been involved in education in different ways, and I want to help every child love mathematics and flourish in it. Why? Because math is beautiful. So when you meet a student at a college and they tell you, I'm struggling with math or I'm in a remedial math class. You need to help them learn the mathematics they need to learn fast and well. That's number one. But number two, you need to then teach them the skills and the mindset that will help them flourish in their journey. So let's talk about it. So we know that in the traditional sense of college remediation, students might be using a software or they might be using a book and they're being assigned all these problems and they're just going through the motions. We don't have to stop there. We can deal with the other problem they're faced with, which is the internal struggle where they might be anxious or discouraged and ashamed of being behind, quote unquote. Some of them have a fixed mindset. I'm just not a math person. I've always been bad at math. Meanwhile, the system is what was failing them, not their math ability. They might be very capable, but the system is just so bad that it makes the best of students become not good anymore. Some of them get bored, and there's just so many reasons, very troubling. Life factors happen. Maybe something happened along the way in 4th or 5th grade and the student was going through a difficult time and that was when fractions were introduced and the student missed the mark and now it has affected them all the way to college. Let's fix this problem. So the truth is we're not just teaching brains and just dealing with people like they're not people. We're helping human beings flourish. That's my model for fixing remedial math education. So students are not broken. The system is incomplete. The system is fragmented. So you have elementary school and then you go into middle school and then you go into high school. But along the way, there's so many opportunities for people to get lost. And we don't teach the history of math. We don't teach the philosophy of math. We don't teach some of the things that will help students to love math. Sometimes because we have to meet the standards. But math is too beautiful to be limited by any standards. It's just too beautiful. A Mathematician's Lament talks a lot about this. A Mathematician's Apology gives another good framework. These are two great books that I recommend for all math teachers around the world. We are helping human beings flourish, not just helping students pass placement exams. That is part of the mindset we need to bring when we meet students at a college who are trying to do remedial math. So there's, in my model for solving remedial math, which I believe will help many schools. If your university needs help to rethink its math remediation plan, let me know. My off-duty role as a physicist is I want to help schools and universities to fix the math education challenges at their school. And so I have some availability to help a few schools to get off the ground, to help many students love math, flourish in math, so it doesn't limit the opportunities of what they can explore at the college level. If they're in college, some people give up on engineering because of their math skills. We can fix that problem. And we can fix it fast. We need to fix it fast because what we want to do is we want to help the students to learn all the mathematics. So that's the first part. In my Counting to Calculus remediation version, which is called Inspirational Mathematics, in my Inspirational Mathematics, right, we're inspiring the students to care. The students need to master pre-algebra, algebra 1, algebra 2, pre-calculus, geometry, and calculus 1. They need to master all of that. That's part of what these workbooks are about behind me and this one as well. The students, they have workbooks. They have a list of topics they're working through. They're going one by one. They have videos they can watch. They have an instructor. For the mastery portion of the content, no problem. They need content knowledge, foundational skills, rigorous structure, skills fluency. Great. Number 2, we need to focus on how are you really doing, John? How are you doing? We need to focus on helping them build confidence. I can do math. I can do it. Not every great mathematician was good all the time. Some of them struggled. We don't tell those stories. I remember sitting in an organic chemistry lab and reading a little bit from Journey Through Genius, which is another book I recommend by William Dunham. And I'm reading this book and I realized something. Isaac Newton was an ordinary guy. I mean, yeah, he was pretty good at this, that, and the other. But like I started reading his story and I'm like, why didn't anyone tell me Isaac Newton's story? Like, tell me about the people that came up with these ideas. Tell me why they were so good at what they did, right? I've been to Isaac Newton's house, by the way. He's not my favorite mathematician. I do like him. But my favorite is Leonard Euler. And then my favorite physicist is James Clerk Maxwell. And we have his book here as well. So this leads me to the other thing you do with your students. They have to know the people behind the ideas. John Napier, with logarithms, we teach logarithms in Algebra 2. He was an amateur mathematician. Imagine if your students begin to see the human side of these people they've been learning about. I think that's huge. So We need to build their confidence. We need to tell them stories. We need to show them the applications of the mathematics they're learning. We need to help them have a vision for their lives, get them connected to a mentor in those fields they're willing to explore. See, what we're trying to do is we're trying to help them flourish as human beings. Remedial math education needs a different perspective, I would say. We need to teach them how to manage stress. We need to teach them that they can do it. They have what it takes. So that means remedial math instructors need to act like coaches. They need to be inspirational because you're dealing with a situation where somebody might not have loved math and now is just trying to get it out of the way and move on with their lives. But math is too beautiful to do that too. Math is too beautiful to just be like, I just want to get it out of the way. No. It's beautiful. And we got to show it to them. We have to tell them the stories. So this approach restores mathematical competence by restoring meaning, context, and belief in the student. Meaning, context, and belief. So we need to give them the foundational mastery, that's what they need. We need to give them the context, and we need to coach them. So students need to have a solid foundation. You can't work on fractions if you don't know prime factorization. You can't work on polynomial factoring if you don't know about factors. There is just no way around it. Mathematics does not respect anybody's age or grade level. It only cares about your mastery-based progression. So we need a solid foundation, we need the context, and we need to inspire them. Teachers need to act like coaches. So in the cumulative foundational piece of this, they're going to learn pre-algebra, algebra 1, algebra 2, geometry, pre-calculus, trigonometry, calculus 1 as one course in a year or less. How cool is that? Give them all of it. It takes about 248 topics to get into calculus 1, and then you move from there. So give me 32 weeks. And I'll help any instructor to build this out so that in less than a year, the student goes from, I was the worst in my high school in math, or I was the worst in middle school, and they start saying, I love math. It makes sense. They see the connections. They have to see the connections. And it's not just enough in seeing the connections of the math topics, it's also seeing the people behind the math topics. So we need conceptual understanding, skill fluency, logical structure. We need a structure to how they're learning. No gaps, no shortcuts, no artificial pacing. They move at the pace of their mastery. So students don't struggle in calculus a lot of the time because calculus is hard. Sometimes it's because their pre-algebra and algebra skills were not as strong. Students struggle sometimes because earlier foundations were rushed, they were fragmented, or they were never mastered. So we need to fix some of those things while teaching them to have the right mindset to mathematics. Mastery at every level unlocks the next. We have an app, we have tools that we've put together, we have booklets, we have resources to help students. And we are also willing to build out resources for people tailored to their needs. So students need to have good number sense, proportional reasoning, algebraic thinking, symbol fluency, logical reasoning skills. They need to have confidence and belief, and a belief that they can do it. And then we give them the right tools to build on. So one of the questions students will ask is, when am I ever going to use this? And we need to help students see that there are times where they're going to use the concepts, like in prime numbers. If you know prime numbers, then you can deal with encryption and decryption better, right? There's applications of prime numbers, but the key is that math is beautiful even if there's no application in sight. We have to inspire them to see that. Okay, mathematics is not some random story. It's part of the human journey, like discovery, civilizations, different roles that have been played. Math opens doors to countless fields and careers, and we need to help students to have those opportunities and not be limited by the methods we use. Mathematics becomes a tool for agency, not a hurdle. So let's raise the bar. Let's encourage our students. Let's give them a clear vision, and let remedial math be a launching pad for more students all across America. I'm excited to provide support, as I said, to institutions around the country who are trying to upskill when it comes to remediation. Inspirational mathematics is the solution to college remediation because it inspires people to realize that they're capable of so much more. I would love to help your students do that. My website is countingtocalculusandbeyond.com. countingtocalculusandbeyond.com. My name is Amos. Take care and have a blessed day.